In this video, I'm going to explain hyperparameters used during the inference of large language models and how can we change the values of hyperparameters to change the behavior of the responses from the large language models. So before going into the main topic, let's ask ChatGPT what is hyperparameter. Explain what are what are hyperparameters when we are referring to large language models and how they can be used during the inference of large language models. Okay, so we got the response. Let's see. Hyperparameters in the context of large language models refers to the configuration settings. So to put it simply, hyperparameters are something which we can use to configure the settings. So these settings you can configure during the training process and also you can configure during the inference. It's written here. These parameters plays a crucial role in determining the architecture and behavior of the model during training and inference. So basically hyperparameters are like a settings or configuration settings which we can change to change the behavior of the training or change the behavior of the responses provided by the large language model. Let's go to the slide and see what hyperparameters we are going to discuss in this video. Top three hyperparameters in the slide you are seeing are called sampling techniques. So let's ask ChatGPT what is a sampling technique. What is a sampling technique when referring to inference of large language models? All right, so we have a response and let's see what ChatGPT is saying. So sampling technique in the context of large language model refers to methods used to generate diverse and creative outputs during the inference or generation phase. So what it is saying is you can use this sampling technique to change the behavior of your inference. So if you want your responses to be more creative, there are some settings you can use to make your outputs more creative. Or let's say you want your responses to be focused, deterministic. When I say deterministic and focus, which means you always want your output to have the same kind of patterns, right? So let's go to the content slide and let's see what's the first hyperparameter we are trying to understand. Top K. Let's see what ChatGPT is saying what top K is. Uh, right, so here it is. So top K involves sampling from the top K most probable words at each step where K is a predefined parameter. Okay, so what exactly it means is, let's say you have given top K equal to 40 versus you have given top K equal to 100. So what it does is large language model selects 40 tokens, most probable tokens, 40 of them, versus it selects most probable 100 of tokens. Okay, and then within this 100 it selects one, and within this 40 it selects one. So let's say you are giving the top K value very less, like 3 or 4 or 5. Let's say you are giving it like 2, right? So it always selects 2 top most probable tokens, and it in the end it always generates either one from these two, right? So your response is more focused and deterministic when the top K value is less, because it always picks the next word from these two tokens, right? So if you put 100, so there are different 100 different tokens and it tries to pick one from these 100 tokens. So that's top K. So to summarize, you use higher top K value when you want your response to be diverse, creative, and you use lower top K value when you want your response to be deterministic or focused. Now let's see what's our second parameter is. Top P. let's see ChatGPT what it is saying about top P. So similar to top K sampling, top P sampling involves sampling from the smallest set of words whose cumulative probability. So this is the key word. It is saying cumulative probability exceeds a certain threshold. So let me show you what it means. So let's say the value of top P, we are trying to analyze 0.4 versus the value of top P, we are giving 0.9, right? But why, what are the ranges of P values? If it's top K, it can be 10, 20, it's a numerical value. It can be 100, 200, 300, it's up to you, right? But for the top P, P refers to the probability, and the probabilities are always between 0 and 1, okay? And just like top K, higher the value, the diverse the response, lower the value, the more focused and deterministic the response is. But why is it? So let's say there is a subset, okay? So let's say there is a subset which has 0.4, right? So for this subset, you will have less tokens inside. If there are 9 tokens, then the probability of coming from these 9 tokens is 0.4, okay? The more the tokens, the probability of having uh, the probable candidates is high. The more the values, the more the probability. Less the values, the less the probability. It's like, let me give an example, okay? So let's say there are 1, 2, 3 white balls, 1, 2, 3, 4, 5 stripe balls, okay? Stripe. Okay, so the when you try to pick a ball, the probability of having a stripe ball is more than the probability of having a white ball, because the less, because the stripe balls are more, the chances of you picking the stripe ball is more, which means the probability is more. The white ball, the number is less, the probability is less. So if you want to increase the probability of white balls, all you need to do is put more white balls in the box, like a lot more than a stripe balls. So when you try to pick, the probability of picking the white ball is more now than the probability of picking a stripe balls. So if you want to increase your chances of picking the white balls, you put more and more and more white balls, right? It's the same thing. So if you put top P value as 0.4, there are only fewer tokens in the subset. If you put 0.9, there are more tokens in the subset, right? So more tokens, the more diverse your response is. Fewer tokens, more deterministic your response is. More tokens, which means you're trying to get creative response. Fewer tokens or deterministic responses are not creative. They always follow the same kind of pattern in the response. So that's top P and top K. So how can we use top K and top P together, right? So if you want more creative responses, you give like 100 value for the top K, and you give like higher value, maybe zero 0.8 should do. So we need to play with these values until we get the right uh, values, right combination of values. But if you want more focused, you may give this less, maybe like 20, and this maybe like 0.4. So you get more focused here, you get more creative here, okay? So that's the importance of top K and top P during the inference. So now let's go to the slide, the content slide, and let's see what's our next parameter is, and it is temperature. Let's see what ChatGPT is saying about temperature. So the temperature scaling involves scaling the logits before applying the softmax function. And it also saying that higher the temperature makes the distribution more uniform and results in more diverse outputs. Lower the temperature, it sharpens the distribution, leading to more focused and deterministic outputs. Two, three key points actually, not two. There is something called logits, and there is something called softmax function, and the third key point is higher the temperature, more diverse the output, lower the temperature, more deterministic or focused the output is. Just like top K, top P, temperature is the same. The more the value, the more diverse, less the value, the lesser the diverse, which means more deterministic. Okay, so if you want to if you want your responses to be more diverse, usually we give temperatures more than one. If you want your responses to be focused, we usually give less than one. Okay, let's understand what logits and softmax function is, and then we will understand why the temperature, the greater the temperature, will give the diverse, and lower the temperature will give the deterministic outputs. Okay, I open the whiteboard, and so let's say that there is an LLM and you are giving an input to the LLM, and what you're seeing is an output to the LLM from the LLM, right? So but there are, in between there are intermediate calculations are happening, right? There are a lot of intermediate calculations are happening to get this output, and one of the calculation is soft max function. Okay, and this soft max function is directly based on the value of temperature. So if you give the value of temperature equal to 1.5, so this soft max function, whatever it does, but one of the variable is this 1.5. So if you give it 0.5, it actually says this variable 0.5 to calculate something, right? Whatever the something is, we will discuss. But what I'm trying to explain is this temperature value is used by softmax, and the greater the value, the greater the value, the softmax function will give uniform output. Okay, or I can say the diverse output. The greater the value, it gives diverse output. The smaller the value, the softmax function will sharpens the output. Okay, so sharpens the output, which means more focused. Okay, right? So now let's see something else. So when you give an input, the LLM will provide or generates a raw logits. It's called raw data, called logits, and this raw data is passed into, let's say this raw data is called R, and this raw data is passed into softmax function. So let's say softmax function is this, so the R is passed here, and then the temperature is passed here. Okay, and then this softmax function will provide some probability value. Okay, probability values. So higher the temperature, more diverse, lower the temperature, more sharpen and more focused. Okay, so that's about temperature. So how do we use top K, top P and temperature together? So as we know, if you are working on an application and application is trying to generate some stories, okay, or it is trying to take the reviews of a movie and is trying to create a blog, so you need more creative content here. Okay, so let's say this is a blog generation application, so you would usually want more creative words, the more diverse words, because you don't want all the blocks to sound the same, right? You don't want them. So in this case, what you do is you top k as maybe 100 and top p as, let's say you start off with zero point 0.7, and you give temperature more than 1. Okay, temperature greater than 1, so it's going to be 1.2. Run it, see the response, then you increase this to 120, increase this to 0.8, increase this to 1.3. So you have to play with it until you see a response which is satisfactory to you, or which is satisfactory to the use case you are doing. Now let's say you are creating an app which is generating some reports, okay, some technical reports. Okay, let's say those reports are analyzing stock, company fundamentals. So you don't want to be creative words, you want to be deterministic words here, because they are technical reports. It doesn't matter if one and the other report, the wording or the wording is the same, as long as the content is good, or as long as you put all the safety guardrails to make sure the content or the reports are perfect. You don't care about the creativity, right? In this case, you want top k as less as possible, maybe like 10, and top maybe like point 3 or 4, or maybe less than this. And temperature, you can put actually 0, or a little bit, or start from 0 and do it until 0.5 and try it. Okay, so this will give more focused, more deterministic responses, just like how we want in our technical reports. Now let's understand the next parameter in this slide, that is repetition penalty. So the name itself says a lot. So you are telling the large language model not to repeat a token. If you repeat, a large language model will be penalized. So the default value in llama cpp and hugging face is 1.1. so if more than 1, the large language model is less likely to repeat tokens. The repetition penalty is used to avoid the repetition of tokens. Then what's the max sequence length? So let's say now your application is to create a blog, and the larger the length is better. So the max sequence length is, you are telling large language model that you can generate to the certain length of tokens. If you give 200 as a value, it actually generates 200 tokens. That's the maximum, and it stops. Large language model will stop. You can give 3000 if your large language model is fine tuned in a such a way that it can give 3000, 4000, or 5000 tokens. Then yeah, go ahead and just give as big as you want. So that is for the max sequence tokens. So there are some use cases where the max sequence length should be small. So let's say your application is creating Twitter posts. That's what your application does, and you're using large language model to create that Twitter post. So you want the max sequence length to be less, right? Not more. So now let's go to the next one, is seed. So seed is just a random value. Okay, it's a random value. So let me go to the whiteboard and let me explain. So let's say you gave a seed as any random value, let's say 45, and you run the large language model, right? So it give a response x. Now, if you run the large language model by keeping all the hyperparameters safe, including the seed as 45, and when you run, it will give exact same response. No matter how many times you run, it still gives you the exact same response. A large language model uses this seed to provide the determined response. Let's say there is input y or input I, you give it to large language model, and you got an output O. You didn't pass any seed, which means if you run this the same input, you might get a different response O1. If you run, you will get another response O2, right? But let's say you run, you have an input, you send it to LLM, large language model, and you gave a seed as 86. So it gives an output X. So the second time when you run and you give the 86, making sure that input is the same, you will get the same exact response. So in which cases this seed is used? So let's say you are using diffuser like a stable diffusion, and you are generating an image, and you want the same image to be generated again and again for the same exact prompt. You use a seed. So enough of theory. Let's go to the code and see in live how these values affects our responses. Okay, so let me check the GPU in my system. Make sure that G free. Yeah, if you see the GPU is free, and I'm trying to load Vicuna 30 billion parameter model, but I am loading quantized 4-bit quantized version. I have only 12 GB GPUs, so there is no way I can run the full 30 billion parameter model, so I'm using the quantized one. So let me load this first. The model is loaded. So now we can create a pipeline. So to generate a text or to generate a response, we need to create a pipeline object. By the way, I'm using the Hugging Face classes. If you see, all these are Hugging Face classes. So we load the model, we create the tokenizer, and then you will create a pipeline. And while creating a pipeline, we can give all the hyperparameters which we just discussed just now, right? So let's see what I'm passing here. I'm passing the text generation. So what is this text generation, right? So let's go into the and see what's the text generation is. If you see here, I'm passing this text generation. So basically what we are saying is, give me a pipeline which actually generates the text. If you see, there's a lot other pipelines here. If you are trying to create a summarization, which means you are giving a huge text and you want large language model to summarize, so you will pass summarization and it will give you a summarization pipeline. But here I am worried about text generation pipeline, so I'm passing the value text generation. All right. Next, I'm giving the model, I'm giving the tokenizer, and then, like I said before in the slide, the max new tokens are something which actually limits the number of tokens generated by large language models. If I want longer, I will give this longer, 2000, 3000. If I think 512 is enough, I'll just put 512. For this demo, I'm just gonna put 512. And the temperature, the less the temperature or less than 1, which means the more focused the output will be. More than 1, it will be diverse or more creative. Then top P 0.95, which means I'm giving a higher value of top P, which means it will be a diverse responses. And top K, it is 40. And repetition penalty is 1.1. So I'm telling large language model that you will penalized if you repeat the tokens, right? So let us run this pipeline, and let us run and see what the response is. By the way, the prompt is, tell me a toddler rhyme but also add some humor to it. So if you see, it's giving I'm a little toddler, whatever, right? So let us do one thing. So let me reinitialize this pipeline with the different values. Now let's say I want this to be more focused. So I will give 0.3, and top K would be like 10, and temperature is going to be 0.4. So I have initialized the pipeline, and let me rerun this. So it's taking a little bit time. The reason, because I'm using 30 billion parameter model. All right, so we got the response and let us try to run again. And the response now we received is something about Humpty Dumpty sat on a wall, Humpty Dumpty had a great fall. So let us rerun this again and see what happens. All right, if you see, because the temperature top P and top K are less, the responses are more deterministic. It still said something about Humpty Dumpty. Okay, so now what we're gonna do is, how about we reinitialize this with higher temperature? Okay, let's say more than 1.2, and top P I'm gonna give 0.95, and top K I'm gonna give 100. So let me reinitialize this, and now let's see. Okay, so now you see the response has changed, but try to run again. So now it's saying something about Humpty Dumpty. He's probably just sunbathing. Okay, let me rerun again. So this is the second time we ran, and if you see now, the response is completely different. I mean, it started with Humpty Dumpty, but I don't know what it's trying to say. Um, let's run again. If you see, this is a whole complete different response. So that's about it. So if you want your response to be diverse, then give the top K, top P, and temperature values the higher. And if you want to be more deterministic, give top P, top K, and temperature value lesser. Okay, and based on how much tokens you think you want, or whatever the application you are building, it depends on the use case. So based on whatever the application you are building, you can actually change the number of new tokens. That's all for this video. Hopefully you like this.